One of mankind's goals for the 21st century is to boldly go where no one has gone before, more specifically our sister planet Mars. But to prepare our brave new class of astronauts for what they might encounter in that challenging environment, scientists are studying previously unexplored regions of Earth. One of them is Dr. Brian Hynek of the University of Colorado at Boulder. Although he hasn't left Earth, he might as well have.
We sort of drove as close as we could and then started trekking out across these salt flats. So it looks like snow. It's just totally flat, extremely bright, burning your eyes. So we headed out across these salt flats, and sometimes we were sinking in up to our knees. It was wet and squishy, and we had to navigate our way out. And eventually we got to these big lagoons. And these lagoons were just sort of unworldly, just a weird bluish green color, and then all these giant mounds of rock underneath the water, about 3 or 4 feet.
He's here to share some of his adventures. I'm Steve Fisher, and this is Life Slices. Who is Brian Hynek?
Brian Hynek is a planetary scientist and a professor at the University of Colorado Boulder in the Department of Geological Sciences and the Laboratory for Atmospheric and Space Physics for the last 2 decades.
Okay, so what led to you becoming a geologist? Did you have rocks in your head?
As a kid, I loved collecting rocks, and I loved astronomy and the stars in the night sky. And so in the end, I was able to combine my 2 passions of studying the rocks on other planets. So I mostly study the planet Mars.
Did you spend a lot of time as a kid cracking rocks open to see what they look like? And I did that all the time. I don't know why, what I was trying to find.
Oh, certainly. Yep. And everywhere we went, I've collected more rocks. And I think my parents just kept throwing them out because they didn't accumulate at the rate they should have.
Okay, so now your bio says that your interests are, give me a second here, cosmochemistry and planetary geology, astrobiology, geochemistry, geobiology, geodynamics, geophysics, remote sensing, geomorphology, and cryosphere. Please explain that in simple English for those of us on just a bit higher intellectual scale than microbial.
Well, I have a lot of interest. I think it's ADD or something. But, I study planets and planetary systems. So trying to understand Mars, you need to understand the physics there and the chemistry there and the rocks and geology there and the atmosphere and the surface and the interior. It all plays together to get at the big question of, was there ever life there? And how do we go about searching for that? So it really is an interdisciplinary science that you need to be successful.
That's a lot of things. How much did you have to study to get to that point where you were an expert in all of these?
My PhD was on planetary geology. I was mapping the landing site for the upcoming 2003 Mars rovers and dried up river valleys all across Mars and trying to use that to get at what the ancient climate was like, how long it was warmer and wetter and more Earth-like, and that's how life could have come about. So that was my background, sort of geology, I'd say, and remote sensing. But then I've just expanded. I've got into trying to understand habitable worlds and environments of places that could support life. And so I spend a lot of time going to extreme environments on our planet, like active volcanoes and right. So if I want to see what life is there, I need to be a microbiologist. So I've just taught myself and through good colleagues have learned the microbiology techniques to figure out what I need to know.
We're going to get to all that in a second, but I want to get a little basis here. What are stromatolites? Am I pronouncing that correctly?
Yes. Yep.
Stromatolites? Okay. And how do they inform our understanding of prehistoric times?
So a stromatolite is an organic layered rock mound. And these exist on modern Earth, not in many places, but they are the oldest fossils that we have in our geologic record. So there are 3.5 billion year old stromatolites preserved in the rocks. And that's the earliest signs of proof that there was life on our planet. And that it was probably even conducting some photosynthesis at that point.
I read that there were actually possibility that there were even older specimens that didn't survive for some reason. Why would that be?
We don't have many rocks left from that ancient time. So between plate tectonics and resurfacing and erosion, most of that early rock record is gone. So we just have a few spots. And so when we go and look at those areas, these are the oldest agreed upon fossil life that we have.
Have you ever considered trying to take a trip to the center of the Earth, just like in Jules Verne, and see what older specimens might be down there?
It would get pretty hot pretty quick as you head down. Even just a couple kilometers deep in the gold mines, it's over 100 Fahrenheit, 150 Fahrenheit. So I don't think I'd want to.
I remember I was hooked on the old 1960 movie with James Mason and Pat Boone, and everything just looked so cool down there. It wasn't until the end when the volcano blew that you saw that it was hot and that there was lava. But for some reason, it was just a wonderful underground area with dinosaurs roaming around and stuff like that.
Yep, great sci-fi.
Now, you found a place, Puna de Atacama. I don't know if I'm saying that correctly. Is it Puna or Puna?
Puna. So it means high desert. So we're looking at above 12,000 feet or so, and in the Atacama. So extremely dry, arid, high elevation, high ultraviolet radiation, pretty barren place. It's a lot of northern Argentina or northwestern Argentina, and it's spilling over into Chile a little. That setting has been there forever.
Oh, but I mean, when you went to explore it, it had been previously discovered.
Yeah. So we're sort of at the edge of where humans exist, down this dirt road, 9 hours to the end of it. It's 9 hours to get to a little bodega store to get groceries or something. So there's about 35 people living in mud huts in a little village there where the one spring is, and they have their llamas and they grow corn and they grow potatoes and just subsistence natives that have been doing that for thousands of years there, presumably.
You have a very strange sense of vacation. Have you ever heard of Club Med?
No, I go to Antarctica for vacation sometimes.
A lot of fun activities down there?
Oh, yeah. We spend 2 months camping in tents, looking for meteorites with a small NASA team in the middle of the continent.
How many meteorites do we tend to discover?
We'll find 800 to 1,000 in a field season of about 2 months out on the ice. Yep.
Why are they all out down in Antarctica? Do we find them other places at the same level?
So we don't find them at the same level other places. We do find them other places. The good thing about Antarctica, a couple of things. One, if you have a black rock sitting on a mile-thick sheet of ice, it probably came from above instead of below. So that helps. And then the glaciers also move, and they concentrate them over time. So like as they flow off the South Pole and then push up against the mountains, and then as the wind ablates away that surface, any rocks that are there all get concentrated sort of along the transantarctic mountains. You've probably stepped on a meteorite just walking around on a hike somewhere, but you wouldn't know because there's just rocks everywhere and you're not looking for them. But in Antarctica, when you're out on the ice in those settings, they're much easier to identify and collect.
Well, you would know it if you stepped on one of those rocks and it cracked open and the blob ate your leg.
Yes.
Pictures of Atacama show a very extraterrestrial look. And it's hard to describe in an audio podcast, but try to describe for us what the scene was like when you got there.
Yes, the scene. So I was looking around the satellite imagery and told my Argentinian collaborator, let's try to get to this place. I think that it's going to be really neat. But no one had ever been there. There's no roads there. So we sort of drove as close as we could and then started trekking out across these salt flats. So if you've been on Great Salt Lake at Lake Bonneville, where this raceway is, it looks like snow. It's just totally flat, extremely bright. You got to wear sunglasses. You're just burning your eyes. And so we headed out across these salt flats, and sometimes we were sinking in up to our knees. It was wet and squishy, and we had to navigate our way out. And eventually we got to these big lagoons. And these lagoons were just sort of unworldly, just a weird bluish green color, and then all these giant mounds of rock underneath the water, about 3 or 4 feet. These were the stromatolites. There were just thousands and thousands of them that filled this lagoon. Just a really unique setting, like nothing that's ever been described on Earth. So it's pretty neat.
From the pictures, it looks like a movie set. It's not like something you would expect to find on Earth.
Yeah, an environment very few have ever had the privilege to see and be there. It's just wild.
You found microbial life. Was there anything bigger than microbial life?
Not that we've looked at yet. This valley that these are in, it's kind of picture Death Valley, sort of bounded by mountains on all sides. And here, though, the mountains are 20,000 feet, have volcanoes all the way around it. It's about 100 kilometers long or 60 miles long. So it's this huge, long valley just surrounded by really high peaks. And so there have been other species documented within this larger valley of like a lizard that has never been found outside of this valley, some other things like that. Our goal was to look for the microbes because those are what are building these rock mounds, and those are what are in the ancient Earth rock record as the earliest signs of life on our planet.
What were some of the challenges that you encountered trying to explore this area?
Well, it was hard to walk because you would sink into the salt and slush, and plus we didn't know what we were going to find, what was there. And really, we found this place on our final day up in this region and had to start driving back the 3 days to get to the airport so I could catch my flight. So we only had about 2 hours at this site. And so we're just itching to go back and trying to get some funding to head down there and do a much larger, more detailed study.
So you are planning to go back if the fates allow.
Yes, yeah. Whenever someone writes the check, whether it be NASA or National Geographic or whoever, yeah, we're pursuing because this site's like nothing that's ever been described. So just from a scientific standpoint, just phenomenal. And it mimics a lot of the earliest life on Earth. And then secondly, they've begun test drilling for lithium mining here. And this could just destroy the entire environment and ruin it forever. So we'd like to try to at least characterize it before it's disturbed and potentially destroyed, and certainly try to then make cases that this should be preserved and mine elsewhere for the Prius batteries.
I was concerned looking at those pictures, and I was thinking, how long is it going to take until this is commercialized and destroyed, which is very troubling to me. When I was joking before about Club Med, I could see somebody wanting to start one there.
You would need an airstrip, I think, or a lot more infrastructure that exists. I mean, there's the little village doesn't even have electricity. They have a generator that they turn on at 6 at night and shut off at midnight. So for 6 hours, there's electricity to the town running off this diesel generator. So yeah, you'd need a lot of infrastructure for your Club Med.
Maybe they could find something in the lagoon that would actually generate electricity for them.
It's very salty. I'll give you that.
So that is awful. I mean, most life cannot live in that salinic environment. Is that correct?
Yeah, that's correct. Right, salt's pretty bad for a lot of species of life. If you ever put salt on a leech, you see the consequences. But it's bad for more than leeches.
Although I'm guessing smoked salmon could survive down there.
Yeah, potentially there's like some brine shrimp or something like that within this. Those have been seen at other salty lagoons in the region that don't have the stromatolites, and it draws in all the flamingos. But there are no flamingos here, so maybe there aren't any. That's our gauge for if there's brine shrimp. The flamingos are there eating them.
So flamingos can take the salinity.
They can. Yeah, and I mean, I do a lot of work in Tanzania, northern Tanzania. It's hypersaline lakes, so way, way saltier than the ocean. The flamingos, there's tens of thousands of them there. There's Lake Natron right on the Kenyan border. But other birds will land in the lake and then fly away, and the salts will just crystallize on them and entirely encrust them in minerals, and they can't fly, and then they die. So you have all these dead salt-encrusted birds all around the lake. The flamingos with those long legs, they can stay above the salt, and that's their evolution trait that helps them survive there and eat all the shrimp when all the other birds try to land there and die.
How does the study of the Atacama relate to our goal of exploring Mars?
I think there's a lot of similarities between early Mars and modern Atacama. And one, Mars, even though there are dried up river valleys and things, it was dry throughout most of its history. So it was desert-like this. Mars never really had a magnetic field or ozone layer. So all that radiation, the UV radiation, just pounds the surface, much like it does at these very high elevation sites that we study. Mm-hmm. So life has to adapt to that. We have to put on sunscreen every half hour, but the microbes have to find ways to, UV light just destroys DNA. So they have to find ways to either rapidly repair themselves or hide under the minerals in a lot of ways. So just the environmental conditions here. And then also on Mars, we find lots of dried up salty lakes. So like if these lagoons dried up, those minerals that are there are the same ones we find in lots of basins on Mars, where we're pretty sure there were lakes that whenever it started to dry out, these evaporated away. They became saltier and saltier. And then these salt deposits, though, do preserve the cells and the DNA, and they help shield you from the radiation environment that would break down the organics over time. So life within the salt could be preserved long term on Mars. So the geology fits, the environment and those environmental conditions fit. So really, yeah, this is a key place to examine, to really look at what Mars was like 3.5 billion years ago and what life could have been there, and then how it could have been preserved.
So do we think that that our best possibility of finding life on Mars would be underground?
Modern life, yes. So, which again is going to be microbial if we find it. It took 3 billion years of Earth evolution before we moved beyond microbes, right? So we're not going to find dinosaur bones or conch shells. There could still be microbes living in subsurface aquifers. There still is likely water under the ground in hydrothermal systems around some of the volcanoes that are probably just dormant. It seems like not that long ago there's volcanic activity, like tens of thousands of years even.
There is no active volcanoes up there today.
No, not like Iceland, but we do think there are warmer regions and areas where there's still hot areas underneath volcanoes that probably are still feeding hydrothermal circulation, like Yellowstone's, but in the subsurface now.
So that kind of conjures up the idea that maybe Iceland isn't quite as advanced as Mars. But I don't want to insult my friends in Iceland, so we'll go there. To what degree can we expect to find more previously unknown or unexplored regions untouched by humans on this planet? Could we find previously unknown life there?
Yeah, certainly. We're a microbial planet. Most of the biomass on our planet is microbes, bacteria and archaea and things like that. And we have just begun to scratch the surface of what those are, how many types there are, all the classes and phyla and everything. It's just, most everything's unknown still to us. So certainly, yeah, we can find novel organisms in these types of environments that are different than ones that others have really started to look at.
So very little chance of actually finding an unexplored region where dinosaurs still exist.
Yeah, I would say so. But in this big valley here, there's this one species of lizard that has never been found anywhere else. So that's probably the ancestor or the modern equivalent of the dinosaur. Yeah, who knows? No, it seems like the asteroid took care of a lot of the life that was on our planet about 65 million years ago.
I have a grandson who would be very happy if a T-Rex was found alive. Probably not in his backyard.
Yeah, I think the bottom of the ocean, that's where you would find the bigger crazy creatures that really we haven't seen very much yet. And people are beginning to do that on some of these deep dives.
There's some very exciting stuff going on. And we spend so much time thinking of what's on other planets that a lot of times we don't stop to think about what's here on this planet.
Right. But if we understand Earth, that'll inform us about potential for life elsewhere. So that's sort of a goal of a lot of my work.
You led a research group, too, in other work, to Laguna Caliente in Costa Rica's, now you're going to need help with this, Poas volcano?
Yeah. Uh-huh.
Oh, okay, I got it. It sounds like an experience right out of a sci-fi movie. Describe it and what you were hoping to find.
So I've been doing a lot of work looking at what life lives inside of active volcanoes. There shouldn't be much, and there really isn't. And so I've been studying in Argentina and Nicaragua.
You obviously like the heat.
I do, yeah. And this particular one, though, has really caught my attention. I've been studying it about 10 years now. And it is probably the most acidic lake on our planet. It is usually negative pH, the scale that we use to measure acid or bases. And almost nowhere can you find negative pH. I mean, this is like probably 100 times more acidic than your car battery acid. So there should be nothing that can tolerate that and live there. And plus, it's hot. It'll go up to near boiling and then drop down and go up to near boiling. And then plus there's eruptions every few weeks, just shooting out of the lake. And so it is, and it's full of toxic metals loaded with arsenic and everything else. But then we found a single species of bacteria that is living and thriving in this lake, in those conditions. And I was there over Thanksgiving, and I accidentally touched the lake water. And immediately my hands, the skin's starting to dissolve, and you've got to like wash it off immediately and treat it because it's that acidic. You don't want to be there, but somehow this thing can survive there and not dissolve away and can, thrive even. So we've been studying this bacteria. It's been pretty phenomenal that something can live there. And that only one thing is also really rare on Earth, where you only have one type of organism living.
Now, this is an incredibly toxic area. Were you able to return with the same amount of people you started with?
Well, you'll never know. It's an easy way to hide a body. Just throw them in the lake and they'll be gone.
How do you prepare for an environment like that?
You wear appropriate gear. So things that if you accidentally sink up to your knee in boiling acid, you're not going to have your skin in contact with that. So you have sort of rubber suits and things like that. You need full face mask, gas mask. If you try to breathe that, you're breathing sulfuric acid into your lungs and hydrochloric acid, and your body doesn't really like that very much. And even with the gas mask on, you're still coughing and your eyes are tearing. And it's a harsh environment, and there's no trail or anything down there. So you're climbing down a loose volcanic crater wall to try to get to this lake. And every time it's a new adventure of how we get there and whether we can get to the lake or not, and whether it's going to erupt while we're there, and you never know. But we go with sort of the guy that monitors the volcano for hazards for the country of Costa Rica. So he's at University of Costa Rica, and they have gas monitors. They have seismic stations to look at earthquakes. Those can help you predict eruptions too. We try to look at the data, and before we go in to see if, today's probably a good day to go, or maybe we should hold off because it looks like magma's moving and probably is going to have an eruption today. But it's still a bit of a crapshoot and rolling the dice when you're down there.
So how do you get a team together for this? Do you go to your students and go, who wants an A?
Yeah, it's funny. My graduate students are thrilled to go to places like this. I don't know if it's ignorance or they're just will for adventure, but it's that drive for exploration and finding something new. It's really neat. They've all come back safe. Well, okay, one postdoctoral, he ended up with second-degree burns, but usually I'm the only one that ends up with burns occasionally.
Do you put that on your resume?
No, but I can tell you the burn ward in Iceland is far nicer and cleaner than the one in Costa Rica. My personal experience.
This has got to be a really tough way to get tenure.
Come on, I'm dedicated to the science.
The pictures looked horrific. I would take a look at that and all the information and go, I'm not going there. That doesn't sound like fun.
Well, okay, so here's one story. We were there in 2017, and the guy, the expert, he's like, we just published a paper based on the gas chemistry. We think we can predict eruptions. And right now, it's totally calm. You could go camp out at the lake for weeks and you'd be fine. So we went and sampled, and then 5 days later, I'm on the airplane, on the tarmac, ready to go home. And I look up toward the volcano and I see this giant plume of ash going up. And it went into a major eruption for 2 straight years, like magma coming out and continuous eruptions at 5 days after we were there. So if we'd been a week later or 5 days later, we'd be part of the volcano now. So they had to go back and revise their paper. I
have considered expatriating to Costa Rica. I hear it's a wonderful place for Americans. I'm guessing not at that location.
No, it's a great spot because you can go to the overlook and look down at the lake when it's clear. So that's nice, but yeah, that's probably not where I'd recommend. When we have extra days, we'll go find some nice beaches and things like that.
That sounds a lot better. For someone so determined to find life on Mars, part of your work, have you tried to get into the expedition for the NASA expedition to Mars?
Well, right now they're working with the lunar program. So first, I've started to fill out the astronaut application a couple of times. I don't know. I love my life that I have, and I don't really want to live in Houston and just have my schedule dictated to me every day for decades for maybe a chance to fly. I'd rather go explore Earth and these wild places that really haven't been studied. So I'm in Colorado. I'm just enjoying what I have. And I don't think a trip to Mars, I would be happy to go to the moon, but Mars is probably a 3-year commitment. And that's a long time. And also it's going to be extremely risky the first decades probably that people are going, because if something goes wrong, it's not like you're 3 days away from Earth like you are on the moon and can get back like Apollo 13. You got to fix it or you're dead. We're gonna have high risks for humans when the first ones are going and paving that path. But the moon, sure, I'd be happy to go to the moon for a week.
I would love to go into space, but let me know when you can beam me up and then beam me back. Brian, where can people learn more about you and your work?
Oh, I don't know. I'm in the midst of trying to update my website at the University of Colorado. Everything's in the scientific papers. So these sort of boring, in-depth scientific studies, you don't want to read those 80 papers.
So when you get your website up, make sure there's lots of pictures.
Yeah, yep, exactly.
Is there any question that you would like to answer that I haven't asked?
Okay, I always get asked, do you think Mars ever had life or anywhere else in our solar system? And I'm surprised you didn't ask that since your life slices.
I figured if you knew of something, you'd let us know.
No, we're keeping under tabs for now.
I'm looking for an ET behind you waving or something.
Yeah, that's why I put the white screen behind me so you wouldn't see him. But no, I think prospects for microbial life on early Mars are great. And we should be able to find that evidence of that in the fossils, because it was very Earth-like for probably hundreds of millions of years. You had rivers and lakes and rain and snow and this whole hydrologic cycle. And it has all the elements you need, all the nutrients you need. We don't know how life started on Earth, but Mars had the same conditions for quite some time. So it would be surprising to me if there never was microbial life on Mars.
So you keep focusing on the microbial. Do you not expect that we would find some kind of larger life somewhere in our planetary travels?
Probably not Mars. So I said it was Earth-like for maybe hundreds of millions of years. It took almost 3.5 billion years to get plants on Earth or animals that are on land. Like everything was in the ocean and just microbes for 3 billion years of life's history. So it takes a long time to develop anything more than a cell or even a few cells. And so Mars just didn't have long enough. Maybe Europa, one of Jupiter's moons, where the Clipper mission is headed there to explore very soon. And so that has a subsurface ocean under maybe 10 to 50 miles of ice, so it's a little hard to access, but that could have persisted for billions of years, potentially, so you might have had enough time. It's a very challenging environment, though, there. For anything more than a microbe, to find your 23-eyed whale, you should probably go to Europa.
So if you really are fixing for an alien of a different kind, you have to just go watch E.T. over and over.
Yeah, or head out beyond our solar system at least.
Well, Brian, thank you so much for being here. I really appreciate it, and much success in your future endeavors.
All right. Thank you very much, Steve. It's been a lot of fun.
My thanks to Brian Hynek for sharing his work on Life Slices. The work he's doing for NASA is of the utmost importance for the future of space travel. Understanding our planetary neighbors is definitely high in our interest. Perhaps there's minerals or vegetation that holds the solution to issues here, such as diseases or new energy sources, maybe even some form of life. But perhaps it's of even more importance for the future of Earth. We don't yet know everything that this planet has to offer. And let's not forget, knowledge starts at home.
If you liked this program, please like Life Slices on social media and subscribe wherever you find fine podcasts. Life Slices is produced by Beatnik Ravens Productions, all rights reserved. Music courtesy of Fesleyan Studios.